the reduction of order so reduction of order is simply reducing the order from second order to first order, because you know how to solve first order equations, right? By assuming y2 is u function of x times y1, which is function of x. Okay? And the assumption is y1 is known. It's either you find it or somebody find it for you, okay? And it's already known. It's given. Right. If that's the case, let's differentiate this, okay? So y2 prime is u prime y1 plus u y1 prime, right? And y2 double prime is u double prime y1 plus 2 u prime y1 prime plus u y1 double prime. Correct? It's just something that I'm just doing it. And we plug them in the original equation. Oh, sorry. P y prime plus q y equal 0. So in this case, we are assuming homogeneous type. Okay, for simplicity, and we plug it in. So u double prime y1 plus 2 u prime y1 prime plus u y1 double prime plus p, and y prime is u prime y1 plus u y1 prime, and plus q, y is u times y1. Okay? Simply plugging in. And we rearrange this equation using with respect to u double prime. I mean u's. We are collecting, with respect to u's. Okay? And then it'll be equal u double prime y1 plus u prime, which is here 2 times y1 prime, and u prime is here again, right? P y1, and that's it, right? And plus u, we are collecting for the terms related to u, so y1 double prime plus p y1 prime plus q y1. Okay? And that has to be 0. If you inspect this equation, you immediately know this one is 0. Correct? Okay? Then, since those are 0, you have only this term, u double prime y1 plus u prime 2y1 prime plus p y1 is 0. Okay? Then definitely you can make it, this is second order, but you can do this, right? U prime y1 plus u y1 prime plus p y1 is 0. That's first order, right? And here assumption is u prime is big U. Okay, another transform. This is simple but transform also. So with respect to U, you can separate. This is separable, first order separable, right? And we are solving that, first order separable equation using this. So du over big U equal minus 2y1 prime over y1 plus p dx. Okay? Yeah, it's separable. And so ln u equal minus 2 times ln y1 minus p dx. Right? So our u, big U, will be 1 over y1 square e to the minus p dx. Okay? So using y1, the known y1, we were able to get u, the big U. But big U is nothing but small u, right? It's the integration. One integration will give you small u, which is this u. Okay? Big U is the integration of this. I mean, the big U. If you integrate it, the big U, then you'll get small u, right? And small u times y1, the known solution, then you'll get y2. Okay? So y2 is So y2 is y1 times u, and that is y1 times big U, integration of big U, right? And the final y is c1 y1 plus c2 y2 all the time. Okay, so take your paper out and solve it by yourself. So x y double prime plus 2y prime plus xy is 0, and suppose you have 1 y1. To change this non-standard form into standard form, right? To figure out p, you have to first figure out p, right? Then you have to transfer it using y double prime plus 2y prime over x. You divide by x for everything, right? And that will be your standard form, right? Then your p is this, right? That's your p. And then the big U will be 1 over y1. I mean, there's a formula there. Okay, so that'll be x squared over cosine square x, because the y1, inverse of y1, right? So e to the minus 2 over x dx. Okay? And that's x squared over cosine square x e to the minus 2 ln x. Okay, that's x squared over cosine square x times x to the minus 2. Okay? And so that's your solution. So that's your big U. And for small u is the integration of big U, which is 1 over cosine square x dx, and which is tangent x. So your y2 will be u times y1. So u is tangent x times y1x cosine x over x, which is sine x over x. Okay? And finally, your final answer should be c1 times cosine x over x plus c2 times sine x over x. Okay? So there's nothing special in it, just straightforward.